It's minus 42 degrees outside. The wind is moving at 80 miles per hour. There are 3 feet of fresh snow on the ground, and it's still falling. And inside this structure, this weird, half-pipe-looking metal shell buried in the Alaskan wilderness, a man is sitting in a T-shirt, no furnace, no gas line, no electricity bill, just warm air, a cup of coffee, and the sound of a blizzard losing a fight against corrugated steel. Now you're probably asking yourself, what is that thing? And why have I never heard of it before? Because what you're looking at right now isn't some futuristic prototype. It's not a science experiment. It's not something invented last year by a Silicon Valley startup trying to disrupt housing. It's an 80-year-old design, proven, battle-tested, used by the United States military in some of the most brutal environments on the planet. And it's quietly being banned across America, not because it's dangerous, not because it fails, but because it works too well. And that makes a lot of very powerful people very uncomfortable. By the end of this video, you're going to understand exactly how this structure survives conditions that would destroy a traditional home. You're going to see the real math behind heating costs that are effectively zero. And you're going to find out why the same country that invented this shelter won't let most of its citizens live in one. Stay with me, because this one is going to change the way you think about housing forever. Let's go back to 1941. America has just entered World War II, and the military has a massive problem. They need to house tens of thousands of soldiers, fast, in locations all over the world. Jungles, deserts, Arctic tundra, remote Pacific islands, places where there's no infrastructure, no lumber yards, no concrete, no skilled construction crews. They need something that can be shipped flat, assembled by untrained soldiers in under a day, and survive conditions that would collapse a normal building. The answer came from a small naval station in Quonset Point, Rhode Island. Engineers are designed to shelter using one of the most structurally efficient shapes in existence, the semicircle. They called it the Quonset hut. The design was almost offensively simple. Curved corrugated steel panels, arched ribs for support, a flat end wall with a door and windows. The whole thing could be packed into crates, loaded onto a ship, and assembled anywhere on Earth by men following a basic instruction sheet. By the end of the war, the U.S. military had produced over 170,000 of them. They went to the Pacific Theater. They went to North Africa. They went to Iceland, Alaska, Greenland, places where the temperature drops so low that diesel fuel gels in its tanks and exposed skin freezes in under a minute. And in every single one of those environments, the Quonset hut performed. Not adequately, exceptionally. Soldiers who had expected to freeze were comfortable. Structures that engineers assumed would buckle under heavy snow loads were shedding those loads automatically. Buildings that should have required constant maintenance were standing without issue after months of continuous abuse. Something about this design was deeply, fundamentally right, and it took engineers decades to fully understand why. Here's the first thing you need to understand about the Quonset hut's relationship with cold weather, and it has to do with geometry. When snow falls on a flat roof, it piles up, weight accumulates. The structure has to resist that weight directly, which means you need strong horizontal beams, deep roof joists, and significant structural support. The average American home roof is engineered to hold about 20 to 25 pounds of snow per square foot before you start worrying about collapse. A single wet snowfall in Alaska can deposit 40 pounds per square foot in a single night. Now look at what happens when that same snow lands on a curved surface. It can't pile up. The geometry won't allow it. Snow hits the arch and immediately begins to slide. Slowly at first, then faster as more accumulates. The structure is shedding its own load in real time. The weight never builds to dangerous levels because the shape itself is a continuous, automatic snow removal system. But it goes deeper than that. The arch is the strongest shape in architecture. That's not an opinion. It's physics. When you press down on an arch, the force doesn't concentrate at a single point the way it does on a flat beam. It distributes outward to the curve, traveling down both sides simultaneously and dissipating into the ground. Roman aqueducts built with arch technology are still standing 2,000 years later. Gothic cathedrals use the same principle. The Quonset hut is part of a structural tradition that predates modern engineering by millennia. Combine all three of these systems, snow insulation, ground thermal mass, and passive solar gain, and you have a structure that is generating and retaining heat from three separate sources simultaneously, without any mechanical heating system at all. In a well-optimized Quonset hut in interior Alaska, a small wood stove burning for 2 to 3 hours in the morning can maintain comfortable interior temperatures for the entire day. Some owners report going weeks without burning more than half a cord of wood. Traditional Alaskan homeowners spend between $3,000 and $6,000 every single year on heating fuel. That's if everything is running smoothly, prices are stable, and there are no supply chain issues. In rural Alaska, where fuel has to be flown in by small aircraft, that number can double or triple. The Quonset hut owner is spending a few $100s on firewood, maybe less if he harvests his own. The math is almost offensive. Now we need to talk about cost, because this is where the story becomes genuinely difficult to ignore. A basic Quonset hut kit, the kind you can order from multiple manufacturers, have delivered on a flatbed truck and assembled with 4 men and a weekend, costs somewhere between $15,000 and $40,000 depending on size and configuration. A larger, fully insulated, finished interior model runs closer to $60,000 to $80,000. The median home price in the United States as of recent years has crossed $400,000. In Alaska specifically, the average single-family home costs between $300,000 and $450,000, requires a $50,000 to $80,000 heating system installation, demands thousands in annual maintenance, and depreciates differently based on the harshness of the climate. The Quonset hut has almost no maintenance requirements. The steel doesn't rot. It doesn't need repainting every 5 years. It doesn't have soffit vents that ice dams destroy. It doesn't have asphalt shingles that curl and crack and need replacement every 15 years. There are no gutters, no complex roof geometry that traps moisture. You put it up, you insulate it, you live in it, and it asks almost nothing of you in return. So why isn't every off-grid homesteader, every budget-conscious family, every person trying to escape the housing market living in one of these? Because the system won't let them. Here is the wall you hit the moment you try to legally inhabit a Quonset hut in most parts of the United States. First, zoning. In the vast majority of American municipalities, Quonset huts are classified as accessory structures or agricultural buildings, not residential. The legal distinction matters enormously. An agricultural building is something you store equipment in. A residential building is something you live in. You cannot, legally, live in an agricultural building, even if it's warmer, safer, and more structurally sound than the residential building next door. To get a Quonset hut rezoned as residential in most counties requires navigating a process that can take years, cost tens of thousands of dollars in engineering studies and legal fees, and still result in denial. Local planning boards have significant discretion, and most of them simply refuse to approve something that doesn't look like a house. Second, building codes. Most U.S. states have adopted the International Residential Code as the baseline standard for residential construction. The IRC was written with conventional stick frame construction in mind. It assumes rectangular rooms. It assumes ceiling heights that are consistent across the structure. It assumes walls that are vertical. A Quonset hut violates all of these assumptions simultaneously. The curved interior walls mean ceiling height varies continuously from center to edge. There are number 90-degree corners. The structure doesn't fit neatly into any category the code was designed to evaluate. Getting a Quonset hut approved for residential occupancy under the IRC often requires hiring a licensed structural engineer to certify that the structure meets code equivalency, meaning it's just as safe as a code-compliant building, even though it doesn't follow the specific prescriptive rules. That certification process is expensive, time-consuming, and not guaranteed to succeed. Third, financing. Even if you clear the zoning hurdle and the building code hurdle, you then walk into a bank and ask for a mortgage on your Quonset hut. And the bank says no, not because you're a bad credit risk, because their appraisal process doesn't know how to value an unconventional structure. Appraisers use comparable sales, other similar properties that recently sold nearby, to establish market value. There are almost no Quonset hut comparables in most markets, which means appraisers often assign them dramatically low values, which means banks won't lend against them, which means you have to pay cash. If you have $40,000 in cash, that's actually fine, but it excludes the vast majority of people who need financing to buy a home. Fourth, HOAs. If you happen to live anywhere near a homeowners association, and approximately 74 million Americans do, you can stop reading. No HOA in the country will approve a Quonset hut. Their CC and RS specify minimum square footages, architectural styles, approved materials, and acceptable roof lines. A semicircular corrugated steel structure fails every single one of those requirements before you even submit an application. The result is a structure that is provably superior in extreme climates, dramatically more affordable to build, essentially free to heat, and nearly impossible to legally inhabit as a primary residence in most of the country. That is not an accident. Here's the part of this story that most people never connect. The American housing industry is a multi-trillion-dollar machine. Home builders, lumber suppliers, HVAC manufacturers, insulation companies, mortgage lenders, property appraisers, real estate agents taking 6% commissions. All of these industries depend on homes being expensive, complex, and constantly in need of maintenance and upgrades. A housing solution that costs $40,000 to build, lasts indefinitely with no maintenance, and costs nearly nothing to heat is not just a competitor to that system. It's an existential threat to it. The building codes that make Quonset huts difficult to permit weren't written by engineers sitting in a vacuum trying to optimize for human safety. They were written with significant input from industry lobbying groups representing the very companies that profit from conventional construction. The residential classification systems that exclude Quonset huts weren't designed with the best interests of rural Alaskans in mind. They were designed in the context of suburban development, where conformity and property values and neighborhood aesthetics are the primary concerns. The Quonset hut survives blizzards. It doesn't survive bureaucracy, but something is shifting. Across Alaska, rural Canada, Scandinavia, Iceland, and New Zealand, places where climate is serious and building codes are less restrictive, the Quonset hut is experiencing a genuine revival, and it's not the utilitarian, bare-bones version from the 1940s. Modern Quonset conversions are extraordinary. Interior designers have discovered that the curved walls create a naturally dramatic architectural space. Owners are lining the interiors with tongue-and-groove pine or cedar, creating warm, vaulted living spaces that look nothing like the corrugated shell from outside. They're installing radiant floor heating into poured concrete slabs for those deeply cold nights when passive solar alone isn't enough. They're adding skylights to the curved roof that flood the interior with natural light at angles you'd never get in a conventional home. Some of these converted Quonset huts are selling on Airbnb for $400 to $600 a night. People are paying premium prices for the experience of sleeping inside a structure that looks otherworldly, feels like a sanctuary, and connects them to a piece of genuine engineering history. The homesteading community has embraced them completely. Off-grid YouTubers and survivalists have documented builds from kit delivery to move-in in under 2 weeks. The entire process, foundation, steel erection, insulation, interior framing, windows, door, completed by 2 to 4 people with basic construction skills and no heavy equipment. A traditional home takes 6 to 12 months to build and requires licensed contractors at every stage. A Quonset hut takes 2 weeks and requires determination. And in rural areas, particularly on agricultural land zoned for farming, ranching, or resource extraction, the legal restrictions largely disappear. If you own 20 acres outside city limits in most western states, you can put up a Quonset hut and live in it without asking anyone's permission. No permits, no engineers, no HOA, no bank telling you what they will and won't finance. The loophole is land. If you own enough of it in the right place, the system that was designed to keep you out of this structure simply doesn't apply. So here's the question this video has been building toward from the very first frame. Why aren't we building more of these? Not in Alaska, not on homesteads, everywhere. The housing crisis in the United States is real and worsening. Millions of people cannot afford to buy a home. Young people are being permanently priced out of home ownership in most major markets. Rural communities are hollowing out because even modest housing is unaffordable. The average American now spends over 30% of their income on housing, the historical threshold at which economists say housing stress begins. And sitting right there, proven for 80 years, is a structure that costs a fraction of conventional construction, survives conditions that destroy traditional homes, and costs essentially nothing to operate. The Quonset hut isn't perfect. The curved walls make furniture placement challenging. The acoustic properties of bare steel aren't pleasant without proper interior finishing. In hot climates, the steel can absorb and radiate heat in ways that create cooling challenges rather than heating benefits. And the social stigma, the perception that living in a metal half-pipe means you failed somehow, is a real barrier that affects how people make decisions. But every single one of those objections is solvable. Interior finishing solve the acoustic and aesthetic problems. Proper orientation and ventilation solve the hot climate problem. And the stigma, that's the one that requires the most work, because stigma is just another word for unfamiliarity. People feared concrete construction once. They feared steel frame buildings. They feared prefabricated housing. Every alternative to conventional has faced the same wall of cultural resistance, and every one of those alternatives eventually found its place. The Quonset hut has survived world wars. It has survived minus 40-degree winters. It has survived decades of bureaucratic suppression by an industry that profits from expensive, complicated housing. It will survive the stigma, too. Because when the temperature drops to minus 42 and the wind is moving at 80 miles an hour and 3 feet of snow have buried everything in white silence, the man sitting inside in a t-shirt with his coffee in his indestructible half-pipe of corrugated steel doesn't care what his neighbors think about his roofline. He's warm. He's safe. He's paid almost nothing to get there. And he's not going anywhere.